Our last video in this series, we're going to talk about assumptions of regression. Now, making assumptions right in life can be problematic and can get you into trouble sometimes. Assumptions and stats are a good thing. They're not a bad thing at all. So, what are assumptions? We talked about this briefly with t-test. They're things that are necessary for the model to work. They're often things that are built into the actual mathematical formulas of how the statistics are run and processed. Um, that are needed in order um, to make things run correctly, right, and to be able to trust your results. Now, I've got to say, we're going to cover three of these, and really only one of these is an assumption. The other two, okay, two of them are assumptions. The other one is more of a rule of thumb. There are more assumptions than this. I'll mention this again at the end, but if you find yourself in a job where you're needing regression more and often, it would be good to go learn more about some of the other assumptions. All right, so the easiest one, this is technically more of a rule of thumb, um, but you want to count, but a very important one still is you want to count up how many independent variables you have in your model. Sorry, this includes control variables too. And you need to have at least 20 cases in your data per independent variable. So if I'm going to put 3 independent variables in my model, I need to have a sample size of at least 60. If I want to put 20 variables into my model, independent variables, I need to have at least 400 people in my sample. So that's something you just want to be in the habit of counting up every time you go to run a model. Do I have enough people for how many independent variables I want to include? The second one, we've already mentioned this before, but with this type of regression, you have to have continuous and ordinal outcomes, your dependent variable. We can't use nominal variables as our dependent variable at all. In that case, we need to use a different type of analysis. Now, having said that, every once in a while, for the final in this class, I allow people to violate that. Um, if that ends up being the case in this class, I'll tell you why. But when we do, I always run the appropriate type of analysis and ensure that they're giving basically the same answer before I let you do that in the final exam. So I don't know yet if this will be a semester where we do that, but just a heads up that every once in a while we do violate that, but only because I've done some background work to make sure it was okay. Um, this last one is an important one. Now, we call this the assumption of independence or the data being independent. The basic idea of this is that when you collect data and you've got this whole spreadsheet of all this data, the responses of one person are not systematically more similar to any other person than they are any other person. Now, let me give you some examples of how this is violated. Families are a great one here. If I collect data um, and I have both husbands and wives, right, or parents, multiple parents from the same families, and I try to run a typical regression on that analysis, and I'm asking questions, say, about marital quality or about the family functioning, those parents from the same families, systematically, their answers probably are more similar to each other than they are some other random person because they're coming from the same family. And maybe they're reporting on the similar or same types of things. So, common ways you see this violated, having more than one person from each household. Or you'll see this in studying schools, where you go collect data on kids at a school, and you're asking things about their academic experience and experiences in the classroom, and you've got 20 kids in this classroom and 30 kids in that classroom and 10 in this other one. But the problem is kids within the same classroom, because they're in the same classroom, their answers might be more similar to each other than they are to people in other classrooms. Or couples, we already mentioned, right? Or maybe you've got multiple employees from the same office, but then you have a bunch of different offices. So um, lots of ways that we potentially can violate this. Now, often in our field, we don't, but it's an important enough of an issue to be aware of. So, places where this is not a problem. If your participants um, are all from the same group. So if I go to a classroom and I get data from 30 people, all 30 people in that classroom, but I don't have any other classrooms, no problem. Or I go get data only from the kids in one family but no other families, not a problem. It's only when I have multiple classrooms, multiple families, and multiple people from each of those things. Um, okay, so what do? You don't ignore it. You run this code right here. And we're actually not going to go farther into this. I'm not even going to process this in our studio, but I just wanted you to be aware of it. Are we going to encounter this issue in our own classroom? Um, no, actually, we're not. But it's an important enough an issue that I wanted you to at least be exposed to it. Now, I mentioned before, there are other assumptions. There are other assumptions about normality, but in a different way than we're used to. Residuals, something called heteroscedasticity. Oh man, I'm always a little bit proud of myself when I can say that word right the first time. Um, so there are other assumptions about how the model's working that are important and tests that you can run to do those. I feel like they're a bit beyond the scope of this class. But if you, again, find yourself in a position where you're using regression frequently, I encourage you to go use those. ChatGPT is a pretty darn good teacher about these things, and you could say, hey, can you teach me about the assumptions of regression and how to test for them? Okay, that's it. You are ready, and in class, we'll work on prepping variables, and the next week we will work on actually testing regression models.